All right, continuing on with our data and statistics unit, we have lesson 5.2, which is about measures of central tendency and misleading graphs. So first let's go over some vocabulary. The mean. The mean of a set of numbers, or your set of data, is essentially just the average. In a data set, you take the sum of all the data divided by the number of items there are. So you just add everything up, divide it by however many there are, and that gives you the average, which is also known as the mean. Median, that is our middle value. In a data set, it's the middle number, or the average of the two middle numbers, when the data are arranged in numerical order. So the big thing with this one is you have to make sure that you line everything up from smallest to biggest, or from biggest to smallest, really doesn't matter. You just need to make sure that they're lined up in order, and then it's the middle number. If there are two middle numbers, let's say there's an even amount of numbers, and there's two in there, you take the average of the two, and that would be the median. Mode. This is what's called the most frequently occurring item or items in a data set. You can have more than one mode. If you have like 12 different things and 3 of those things happen twice, and that's the most that anything occurs, you would have 3 different modes. That is okay. So mean, median, and mode are our measures of central tendency. Okay, these are all going to help us find how centralized, or kind of the middle piece of our data sets. Now we have a couple other things to look over. An outlier. An outlier is a individual value that falls outside the overall pattern in a data set. So let's say we had a bunch of numbers like 3, 4, 7, 2, 5, 6, then all of a sudden 120. Well, it seems like all of the other ones were pretty small numbers, like less than 10, and then all of a sudden we had a 120. So even though it's just one number, it's way outside of the rest of the other ones. It falls outside of that pattern. That would be what's called an outlier. And our last word is univariate. U-N-I, una, means just one. Variate means kind of like variable, or one thing that's changing. So a univariate is the analysis of a one variable statistic. So if there's really only kind of one set of numbers, that's one variable, so it'd be univariate if we try to analyze that set of numbers. So let's go dig a little bit deeper into these ones. We got the mean, median, and mode. These are the measures of central tendency. So again, these are the numbers used to describe the center or the middle of a set of data. The most commonly used measure of central tendency are the mean, median, and mode. And again, we've kind of gone over these. Mean basically just means the average, median just means the middle, and the mode means the most common. It is important to look closely at the data to see which measure of central tendency should be used. So we will use one of these, the mean, the median, or the mode, when. So we will want to use the mean to describe our data when the data are spread out and you want the average of the values. If you're looking for an average, say kind of the regular, or just what should happen in a sense, you would use the mean to describe it. If your data contains some outliers, some things on the outside either too big or too small, you might want to use the median to describe the middle of all of your data. Even though the outliers are kind of, they're really big numbers, they're going to throw off the average. They really won't throw off the median that much. So that'll help show kind of the middle of all of your numbers. And then the mode. You'd want to use the mode to describe when the data are tightly clustered around one or two values. So if you've got a lot of numbers happening around the same number, you might want to use a mode to describe, like, this is the most common value of all of them. So when we are going over or looking at some of our data sets, this is a quick little warm-up. This will always help you find the median. We're just simply going to write the numbers from least to greatest. So if we have number 1, this set of numbers, 8, 6, 4, 9, 3, 5, 6, we need to write them from least to greatest. Well, that'd be 3, 4, 5, 6, 6, 8, 9. Now, when you write it in ascending order like this, so smallest to biggest, it makes it a lot easier then to help find the mean, median, and mode. If you wanted to find the mode, you just say which number happens the most. It looks like 6 happens twice. No other number happens twice, so 6 would be our mode. If we want to find the median, we just cross off 2 at the end, the next 2 at the end, the next 2, and our middle one right there, there's our median. So our median would be 6. Nice and easy. You can't do this, though, until you've arranged them from smallest to biggest or biggest to smallest. Really doesn't matter either way. So let's do this with another set of numbers. Number 2, we've got 72, 68, 69, 71, and 72. Rearrange them. We've got 68, 69, 71, 72, 72. Again, it makes it nice and easy. We can kind of see 72 happens twice, here and here. That would be our mode. If we wanted to find a median, cross out 1, cross out 1, cross out 1, cross out 1, whatever's left, right in the middle, there's our median. 71, that is kind of the exact middle of our numbers. All right, let's look at number 3 then. We've got 112, 101, 98, 120, and 101. Rewrite it so we have 98, 101, 101, 112, 120. What would be our mode? 101 happens twice. No other number happens twice, so that would be our mode. To find the median, again, it's the exact middle. Cross out 1, cross out 1, cross out 1, cross out 1. There's our median. 101 is both the median and the mode. So that'll kind of help us understand if it's 2 of those, the median and the mode, that probably means that's a good center spot. Everything else should kind of be revolving around that one position. And the last one, we've got 3.74, 3, 3.7, 3.3, and 37. So again, we'll write them in ascending order, 3, 3.3, 3.7, 3.74, and 37. Now, if we're looking at these and we wanted to look at an outlier, this 37 is a pretty obvious case of an outlier. All of these numbers are less than 4. In fact, they're all around 3 something. This is just straight up 3. This one only goes as high as 3.74. But they're all kind of around 3. Well, this number all of a sudden is 37, which is like 10 times bigger than all these other numbers. So this one is a pretty obvious outlier. If we were to take the median, add all these up and divide it by 5, because there's 5 numbers, this number is going to make the median really, really big, even though all these other ones are around 3. So this one is going to throw off our median, or our mean, the average, but it doesn't really affect our median. We just start crossing out the numbers there, find our middle piece, 3.7. Nice and easy. That's still our median, even though we have an outlier. So let's look at some other examples. 6 high school students are participating in a 1-week readathon to raise money for the school. We're going to use the graph to find the mean, median, and mode of the data, if you leave out Latana's pages. So, working towards finding the mean, again, recognizing that we're leaving out Latana's pages. We're not going to include this bar. So, when we want to find our mean, all we're doing is adding up all these numbers and then dividing by however many there are. We have 1, 2, 3, 4, 5 different people here. So, we will add up all of their pages, 40 plus 45 plus 48 plus 50 plus 50, and we're going to be dividing that by 5 because there are 5 of them. When we add all those together, we would get 233, still divided by 5. 233 divided by 5 is 46.6. So this is going to be our mean value. When I say mean, I mean to say that it's our average. This is the average. Each person read, on average, 46.6 pages. Median. Median just means the one in the exact middle. So cross out 40, cross out 40. Cross out 45, cross out 50. One left in the middle right there is 48. So that is going to become, I'm going to get rid of those pieces. That would be our median, is 48. It's right in the exact middle. Mode is the most common. We have 40, 45, 48, 50, and 50. The only one that happens more than once is 50. So 50 is going to be our mode. So notice all of these, 46.6, 48, and 50. They're all kind of around the same place. They're all in between these 3 middle values right here. So these show pretty good measures of central tendency. Let's look at some more examples of these. If we were looking at the mode, Now again, remember, different sets of data can have more than one mode. They also can have no modes. And by that I mean to say they would have no values that double up. So in A, we are looking for how many modes, if any, does each have, and we need to name them. We got $1.10, $1.25, $2, $2.10, $2.20, and $3.50. None of these repeat. Every single one of them only happens once. So we'd actually say that there is no mode in this case. Nothing happens more than once. There is not a most common number. So let's look at B then. 1, 3, 4, 6, 7, 7, 8, 9, 10, 12, 12, and 13. This one actually has two modes. I'm just going to put a 2 and a comma here. What are they? 7 happens twice, and 12 happens twice. So we would say 7 and 12. These are both going to be our modes. Okay? Like I said before, it is okay to have more than one mode as long as each one of them is happening the most number of times. Both of these happen twice more than any other number. This one, our data is not even numbers. It's just names or labels. We have tomato, tomato, grape, orange, cherry, cherry, melon, cherry, and grape. Now this one might be a little bit difficult because they're not necessarily assigned all together. If we counted up each thing though, tomato happens twice. There's 2 of them right here. Grape happens twice, once here and once here. So grape has 2. Orange only happens once. Cherry happens 3 times, 1, 2, and 3. And melon only happens once. So in this case, which one of these would be our mode? It would be cherry, because it happens 3 times, more than any other thing. How many modes does this have? We would say that there's only one mode, and it is cherry, which occurs 3 times. Outliers. Let's look at some examples of outliers given our data. Now, if we were given 7%, 4%, 10%, 33%, 11%, and 12%, one of the things that will help us the most with this is to put it in ascending order like we did before. We're going to start at the bottom, 4%, and work our way up to 33%. This helps us organize our data and see it a little bit easier. Now when we're looking at the data and we're asked which of these values is an outlier, we can see 4 and 7 are pretty darn close to each other. They're only 3 away. And in fact, 7 is only 3 away from 10. So these all seem to be pretty darn close to each other. 33, on the other hand, being the biggest over here, is not only 3 away from 12. It's 21% away from 12. So it's almost triple this amount. So this 33 is obviously going to be the one that is way outside the normal pattern here. So we would say 33% is our outlier. Now, how does this outlier affect the mean? Well, if we were to add them all up, 4 plus 7 plus 10 plus 11 plus 12 plus 33, and divide by 6, because this is how we find our average, this is our mean, this would be 77 over 6, which would become a 12.83. So, with all of these numbers together, we would say the average is 12.83, which is kind of funny because 12.83 is actually bigger than this number. Our average would be way over here. So this doesn't really look like it'd be somewhere in the middle. This looks way further to the right side. So let's see what the average or the mean would be like if we didn't really have that outlier. So if we were only using 4, 7, 10, 11, and 12 and only divided it by 5, because there's only 5 of them, we would now have 44 divided by 5, which would give us about 8.8. Or in fact, to give us exactly 8.8, which would be somewhere in here, in between 7 and 10. Now, if we didn't have this one anymore, and we were just looking at this one looks like it's much more in the middle. Okay, this 8.8 is clearly more in the middle, or at least right next to this middle number, versus this 12.83, which was way further to the right. So the outlier affects the mean by drawing it too far to one side. How does the outlier affect the median, though? Well, let's erase this. Let's calculate the median with this one in place. So we'll cross out the last, cross out the next last, and we're in between these two. So we want the average of 10 and 11, so we'd have 10.5. So that would be one median if we included that 33. Let's say we didn't include 33. We're going to get rid of it. Now let's find the median. 4 and 12, 7 and 11, and we'd have 10% then. So we can either have 10.5% or we can have 10%. So in that case, it looks like the outlier really doesn't affect the median that much. This is why when we have outliers, or a fair amount of them on one side or the other, it might be easier to use the median to describe the central tendency of our data instead of using the mean, because the mean is affected so much by those outliers. Let's look at how we can use means in calculations. For example, we have Kimiko's mean score on the first 3 tests in her history class is 87%. There's one test remaining in her grading period. What score does she need on the last test in order to have a mean score, an average score of at least 90? Well, if there were 3 tests at first and she had an average of 87, we should be able to take 87, the average, times it by 3, and that'll give us the total number of points after those first 3 tests. So after 3 tests, she has a total of 261. Now, if she wants to have an average or a mean of 90 after the last test, so remember that means there's one more, so there'd be 4. If she wants to have an average of 90 after 4 tests, we'd have to do 90 times 4 to get the total amount of points, which would be 360. So if her total right now is 261 and we need it to be 360, we would take 360 minus 261, and whatever we get will be how much she needs to get on the next test. That would be 99. She will have to get a 99 to get her average score up to a 90. Let's run the same problem but with some different numbers. This time, her first 3 tests average out to an 86. She only wants it to, she wants her mean value to go up to an 89. So again, this case, 86 to 89, she needs to grow by 3% or 3 points. 87 to 90, growing by 3 points. Let's see if she needs that same exact 99 though. So we'll do the same exact steps as we did before. 86 was her average, times there were 3 tests, which means her total at this point is 258 points. She wants to have an average of 89. That would mean that she would have to take 4 tests. So 89 times 4 would be 356. If this is the total she needs, and this is the total she has, the total she needs minus the total she has is what she needs to get on the next test. She would need to get a 98% to get an average of 89. Let's move on to looking at misleading graphs. Now there are a number of ways in which graphs can be distorted, either intentionally or unintentionally. Actually, let's leave that till our next video though.